Okay, here we go. We have a story problem about driving with John and Barbara. Let's see if we can figure it out. We're told that John takes 20 minutes longer than Barbara does to make the 156-mile drive between two cities. Barbara, the speed demon that she is, drives 3 miles an hour faster. How fast do John and Barbara drive? We're given a hint here, and that's to use this distance equals rate times time. The distance that's traveled is equal to the rate of speed times the amount of time traveled at that rate. And so we're going to make use of that. Let's get a couple of variables to represent what it is we're looking for. So we're looking for the rates. So we're going to let x equal John's rate, and we'll let y equal Barbara's rate. So we're trying to find x and y. That's what we're trying to find. And we have two unknowns. That means we need two equations. The first one we can get from the fact that Barbara drives 3 miles an hour faster. All right, so that means Barbara's rate minus John's rate. If I take Barbara's rate and subtract John's rate, I get 3 miles per hour faster, right? So, or another way you could say that is that Barbara's rate is John's rate plus 3. Either way, those equations are equivalent. Okay, now we want to use the fact that John takes 20 minutes longer than Barbara to make the 156-mile drive. So let's see what we have here for that. We're going to let capital J equal John's time. That should be a capital J there too. And we're going to let capital B equal Barbara's time. Okay. Well, one thing we know is that John takes 20 minutes longer than Barbara. So John is equal to Barbara plus 20 minutes. Well, everything's in miles per hour when we do our rates. So we have to figure out what 20 minutes is in terms of an hour. Must be 1/3. So John's time is Barbara's time plus 1/3 of an hour. Okay, now what is John's time and Barbara's time? Well, let's go over here to decide that. We're using the fact that distance equals rate times time. They're going the same distance, 156 miles. So 156 is equal to John's rate, which we're calling x, times John's time, which we're calling j. And 156 is also equal to Barbara's rate, which we're calling y, times Barbara's time, which we're calling b. Okay, so I'm going to solve these for j and b. We have here that j equals 156 over x. And here, dividing both sides by y, b is equal to 156 over y. Now I'm going to use the fact that j equals b plus 1/3. So since j equals b plus 1/3 of an hour, John's time equals Barbara's time plus 20 minutes, we're going to substitute our x and y in for that. So I have that 156 over x equals 156 over y plus 1/3. Okay. We've got denominators here. We've got our two equations, by the way. So here's our first equation that came from the fact that distance equals rate times... that came from the fact that Barbara drives 3 miles an hour faster. That's this equation right here. And the equation that came from the fact that John takes 20 minutes longer is this equation right here. So we've got our two equations for our two unknowns, x and y. We've got to solve these. What I'm going to do next is multiply this by the common denominator of 3xy. So 3xy. When we do that, we get the x's cancel here. We get 3y times 156. And 156 times 3, I think, is 400. I want to make sure I got this right. And 68. Yeah, let's just double. Yeah, 468. So the x's cancel. I've got 468y equals here 3xy times 156 over y. The y's cancel, and I have 468x. Plus here, the 3's cancel. We just have an xy. Okay, now I'm going to make a substitution. Let's go ahead and use the fact that y equals x plus 3. So y equals x plus 3 is going to go in here and here. Okay, so I'm replacing y with x plus 3. So we now have, coming up here, 468 times x plus 3 equals 468 times x times x plus 3. Hey, it's a single variable equation. It looks like it's going to be a quadratic. Let's see what happens. I got 468x plus 468 times 3, which is 1,404, equals 468x plus x squared plus 3x. It's a quadratic, highest power is 2. Notice that I can subtract 468x from both sides to get rid of those terms. I'm going to set it equal to 0. I'm going to subtract 1404 from both sides. So minus 1404 minus 1404. So I've got that 0 on the left now is equal to x squared plus 3x minus 1404. All right, how do we solve this quadratic? Well, you can use the quadratic formula. And in fact, let's go ahead and do that right now with an a of 1, a b of 3, and a c of negative 1,404. It's going to factor, but it's hard to see what that factorization is. So x is equal to, again, negative b plus or minus the square root of b squared minus 4ac, all of that over 2a, which in our case is equal to negative 3 plus or minus the square root of 3 squared minus 4 times a, which is 1, times c, which was negative 1,404, all that over 2 times a, which is 1. All right, so far so good. And so we have that x is equal to negative 3 plus or minus the square root of 9. Here I have a negative times a negative, which is going to be a positive. 4 times 1,404, it turns out is 5,616. All that over 2 times 1, which is 2. That's negative 3 plus or minus the square root of 9 plus 5,616, which is 5,625. So we have the square root of 5,625, which it turns out is a perfect square. It's 75. So all that over 2. So it's negative 3 plus or minus 75 over 2. So that's equal to negative 3 plus 75 over 2, or negative 3 minus 75 over 2. Well, negative 3 plus 75 over 2, if we come over here, is equal to 72 over 2. That's 36. That's one solution. Negative 3 minus 75 over 2, that's equal to negative 78 over 2, which is negative 39. Remember, x is representing a rate of speed. How can we be driving a negative rate? Well, we can't. So our answer here is 36. We go back to our problem here. We get that x is equal to 36 or negative 39. Well, it can't be, again, negative 39. So 36 is our answer. And what is y then equal to? Well, remember, y is x plus 3. So y is 36 plus 3, or 39. So this is Barbara's rate is 39 miles per hour. Again, that's 3 miles an hour faster than John's rate of 36 miles per hour. So here are our solutions for John and Babs. And that is the end of that problem.